Okay, so this is also examples of continuity. Determine whether the function is continuous at these 2 points here. So of course, you see there is a changing of function, right? So this is a piecewise function. So means after 1, before 1 and after 1, there is a different function here. So maybe these two function is not continue, means they are not joining, okay? They may be separating. So these two also we don't know. So we have to either be sketching the graph to see, or we using the concept of continuity, right? So in this case here, of course, I want to use the definition of continuity. So the definition of continuity is if we said that the function fx continuous at a point, right? If you set a function approximate at a point, the first thing is the limits of from the right and from the left must be the same, right? Limit from the right and from the left must be the same. And this first condition is applied only for piecewise function, because piecewise function you have right and you have left, right? So there are functions you don't have right left, because the right left they have still have in the same function. Alright, so okay, number 2, of course the limit must exist. Limit of x approaching a must exist. Exist means there is a value. Alright, there is a value. So number 3, so the limits as x approaching a for fx will be also L. Sorry, the value of FA, the value of FA will also be L, right? So if this 2 is actually, this 2 is the most important one. Limit exists, and the value of L, you're getting L, and now I simplify for you. All right, getting L, and this value, the limits near to this point, and this value is L, and FA also L. So we say that they are continuous. Okay, let's look at this one. So because this question they involving 2 points, right? So we go one by one. We talk about x equals to 1. All right, for x equals to 1. So we have to go for, because this is the piecewise function, so you have to consider right and left here. So you look at 1, right? This 1 here. So this is before 1, x less than 1. So 1 minus is in this region, right? So this is greater than 1, x greater than 1. So it means that 1 from the right, this will be the function 3. The limits of a constant, you get back the constant by the properties of limits in the early of this chapter. So if you have limits as x approaching 1 from the left, this is from the right, x more than 1, so 1 plus you have 3, right? So now from the left, x less than 1 means from the left, so 3x, so 3x, so you are getting 3 multiply 1, right? Substitute 1, you're getting 3 also, means limit do exist. The limit exists, x approaching 1 for fx. Means that fx at this point, the limits is 3. Yes, the second condition is L, right? This is your L. But we see whether f1 exists or not. Whether f1 defined or not. Yes, f1 is defined. There is an equal here. Alright? Can you see that? There are no equal, so we choose the one that have equal here. So means that 1, you put thing into the 1. So means that f1 is 3 times 1, which is also 3. Which is, this 3 condition is obey. Memenuhi 3 syarat ini. So therefore, fx is continuous at x equals to 1, right? What's the reason? Reason is these two must be the same. Alright? The limit as x approaching 1, right, is 3. f1 also 3, so it's equals to f1. So this is the reason. Alright? So now I want to do for, okay, means that 1, these 2 graph is connected. Okay, it's connected. So how about these 2? Alright, these 2 graph here. So we have to check the point 6, right? the point at 6. Okay, let's look at it. Okay, now let's look at point x equals to 6. Alright, at point x equals 6. Just now 3, yes, it's continuous at 1, sorry, at 1. So at 6 also, the first condition, this is a piecewise function, so you have to check for the right and for the left, right? For the right and for the left. So the right 6, this is x greater than 6, x greater than 6. So this in this region, right? So which is x squared minus 3. So if you substitute, you have 6 squared minus 3, 36 minus 3, you have 33, right? So you have 33. So then let's look at for the left hand limit of 6. Okay, left hand limit of 6. So x less than 6, right? Less than 6. So means here is 6 minus in this region here, right? In this region here. So you will have 3. Limits of a constant, you're getting 3. You just try to observe. This 2 value is different, right? This 2 value is different. So means that the limit does not exist, you know. Means that fail. So fail. So no need to check. No need to check for the third condition here. Because 2 already failed. So means that fx is not continuous. Or you can write this thing is synonym to discontinuous. Alright, fx is discontinuous at x equals to 6. Right? Fx is continuous, is not continuous as because if they ask you to state the reason here very simple. Because the limit does not exist. The limits as x approaching 6 does not exist. Does not exist. The value is not the same. So there are no value for limit x approaching 6 here. So now I have already concluded that it's continuous at 1 but not continuous at 6. Alright, for extra knowledge, I will sketch the graph for you. Okay, let's see. Alright, so I'm going to sketch the graph to show you graphically that the meaning of discontinuity here. The continuity and discontinuity. So there is 2 boundary value here, which is 1, negative 6, alright, negative 6 and 1, right, negative 6 is 1. So, it's 1 and negative 5. You have negative 5, alright, you have negative 5, you have 1, then you have 6. You have 6, so you have 3 value here. So this is a straight line. From negative 5 to 1 is a straight line, 3x. So 3x, so you know the graph, you can substitute the value because this is a straight line. Straight line, you just need 2 points, right, to sketch. So negative 5, 3 times negative 5, you have negative 15. Alright, I just roughly sketch and tell you. So there is a negative 5 empty hole here because no equal here. So you're getting revision of the sketching of graph of piecewise function. So, and during 1, right, 1, if you're putting 1, 3 times 1, 3 times 1, you have 3. This one you have negative 15, right? So you have 3. So here you have 1, 2, 3. Okay, around here there's a 3. So, okay, they were passing through 0, right? This is the curve mx plus c. So you know that it will passing through here, and so I highlight this one. Okay, so okay, this will be a straight line. This will be a straight line for this part here, the first part here. So let's move on to the second part here. Within 1 and 6, 1 to 6. So this is 3. 3 is a constant function. A constant function here, the fx refer to y. So which is 3. So from here to here is 3. So there is an empty circle here. So 6. Okay, no, this is a solid circle because includes 6. F6 is 6. Alright. Based on this, your F6 is equals to 6. Alright. So this will be the graph. You see, it's continuous here. from the left, from the right. At this point, f1 is 3. Limits from the right of fx is also 3. Go to 3. This one also go to 3. So from the left, the limits for detail for you from the left is also 3. 3, 3, 3. Sudah bukti, continuous just now, right? So how about this one? From the left, the limits from the left. Refer to the calculation just now. So x from the left, 6 minus. From the left, you're getting 3, going to 3. But let's look at the left here, right? So 6 to 10. So it's a quadratic. You're putting 6, you have 36 minus 33. So you have 33 here. 33 here. And this quadratic is actually looking like this shape, right? It's actually your y-axis and your x-axis. They will intercept at -3. Means there is a -3 here. The graph's supposed to be this way. So during 6, it is 33. Alright? Empty one, so without include 33 and up to 10. 10 will be 100 minus 3. Very big number. So I know that if at 10, they will go very high, right? But it doesn't matter there. So the problem is here. The problem is here now. This is called discontinuous, not continuous. Discontinuous. Because why? The limits from the left, 6 from the left is 3. But from the right is 33. Limit as x from the right of 6, you're going to 33. You see the value are different. The value are different means this 2 is actually discontinuous. Okay, I think I have already explained the concept of continuity. Alright, so this is the first 3 example. This is the 3rd example that I already explained the concept of continuity graphically. Continuous, discontinuous. Alright, that's all for this video.